Hi, this is Vijay Kushwaha, and here I'm giving short knowledge on 5G technology. Welcome to 5G technology session, and we'll start with the agenda. Agenda is let's start first introduction on 5G technology, then lab setup. In the lab setup is installation diagram, MTP, new radio, hardware and software descriptions. On-site integration, there is a scripts, network adapter and security settings, LMT integration and consistency check. After that, we will start call flow, call test and trace, and all those things. So let's start for the introduction. So for the 5G technology, we'll start with the 5G definitions, right? 5G definition basically 5G defined by what is called IMT 2020. So remember, IMT 2000, sorry, IMT 2000 was 3G, and advanced was 4G, and 2020 is 5G. So every 10 years there is a generation, right? So IMT 2020, the way these things work is that they first start with the vision. Vision is the C, that is what we want to achieve by the 2020. Then they start working and then achieving. So until 2020, this will not be achieved. Only we will know what this 5G is, because they are going to try to get there, right? But this is the vision, this is the requirement to setting up, and hopefully somebody will make the equipment like this. So what is the way to specify the requirement is to fill the 8 dimension. You can see in the slide 8 dimension, like peak data rate, user experienced data rate, spectral efficiency, mobility, latency, and so on. What should be the peak data rate in 2020? The vision is to 20 gigabits per second. In 4G, it is 1 gigabits per second. So they want to be a faster than 20 times, like 20x. Right? In 4G, it is 1 gigabits per second, and for 5G it would be 20 gigabits per second. Now next is what should be the user experience data rate. So even though the channel is 20 gigabits per second, gigabits, you don't get the 20 gigabits. There are so much signaling overhead, this and that, and so on. But you can still get 100 megabits per second. In 4G, that number is 10 megabits per second. We are 10x for 5G. Now, spectral efficiency. Spectral efficiency you don't see as a user, but the carrier sees. Right now in 4G, it is 1x. If it is 1x, then in 5G it would be 3x, that is 3 times. Whatever bits per hertz you are getting, you should get 3 times more for the same amount of spectrum. So now you are going to up to 20 times, and you are going to 3 times here. So you need to more hertz to get 20 times. So that basically this is that we want to 20 times more throughput, but only 3 times more efficiency you will get. Now next is mobility. You can see here 4G covers 350 kilometers per hour speed, and 5G will allow 500 kilometers per hour, up to 500 kilometers per hour. So this 350 like more car, or we can say high speed cars, I suppose. And 500 here, 500 is more like trains, high speed trains. Sometimes we can consider it as a aeroplane with this speed. Now latency. Latency is very important for some applications, and therefore we want to go by factor of 10th down, right? In 4G it is 10, but for 5G it would be 1. Yes, 1 millisecond. Lower latency is better. So when you want to do something, you get it done in 1/10 time. Connection density. Connection density, that is, connection density basically means how many devices per kilometer square. That is how many phones can be there in a one place, right? And we want to go there from 10 raised to 5 to 10 raised to 6. 10 raised to 6 is a millions phones, right? If we are taking about sensor here, so every homes hundreds of sensors. If you take our neighborhood, so phones might be tens, but there is hundreds of sensors. So that is what it is, device per kilometer square. Device is a sensor. Now network energy efficiency. How much energy does it take to send many bits? You want to go 100 times from 1x. Four G is 1x, and it would be for 100x for 5G. Why it's so much energy emphasis? Because it is IoT. Area traffic capacity. Just like we have a connection density, where so how many devices and how much traffic there, right? So it is from zero point 0.1 megabits per second per meter square to 10 megabits per second per meter square. Okay, this is like how many cameras you can put, because that is the have a lot of throughput, uh, you know so that is the right thing is, it has to be from 0.1 to go to 10, which is 100 times, that is 100x. This is very, very ambitious. So now in this picture you can see both 4G and 5G, and this is a good way to have a vision at least. In this slide, this is actually from reference ITU recommendation M.20830 IMT version, and there are lots of figure out for the 5G definitions. So this is the for 5G definition. Okay, we will continue for further applications, layers for 5G, frame structure and all. Okay, thank you.